You can.
Okay, I will open my cam. Okay. Okay. Hi everyone. I am here to present to the abstract entitled Oxytetracycline induces anxiety-like behavior in adult zebrafish. Since the discovery, the antibiotics are present in all animal production, since cattle, pigs to bees and fish. The applicability is high each year. The fish production growing up all the years around the world, and fish are constantly exposed to antibiotics. But the question is, why is it important to discuss the antibiotics use? Is because, for example, in Chile, 1 ton of salmon need approximately 337 grams of antibiotics, and the main use there is oxytetracycline, 1.2%. This total is the smallest amount used since 2007. We used zebrafish to test our antibiotic, oxytetracycline, because this is an excellent model to study the complex behavior, to study the behavior repertoire that is very well described and is applied to translational studies. Well, we exposed the fish to oxy for 96 hours, and after we tested the animals. During the exposure period, water was changed daily. The P was 7 and 7.5. In our light dark period was 10 hours. Before exposure, we used the random animals because were captured from different aquariums to keep the originality principle. Well, after 96 hours exposed to oxy, the animals were tested in novel tank tests. Which behavioral data were extracted from the novel tank tests? First one, locomotor parameters. What type of locomotor parameters? Distance covered in the tank during 5 minutes. Freezing, that is time that the fish stay not moving, and erratic movements. For other hand, we used anxiety parameters. What type of parameters was analyzed to see anxiety in fish? The latency to first in the top of the tank, entries in the top of the tank, and the time that fish spent in the top of the tank. Well, first we analyzed the locomotor parameters and see that the distance covered, freezing, that is time not moving, and erratic movements were not altered in any concentration, neither 10, 20, and 100. But in the second analysis, we observed that latency to first in the top during 5 minutes was superior in 10 milligrams per liter when compared to animals control, here in the first graph. This is an indicative that had anxiety in the animals. And entries in the top reduced in 3 concentration, most in 10, and the time that fish spent in the top also reduced. Well, with this, observed that 10 milligrams per liter of oxy have more prominent results, we decided just to test 10 milligrams per liter. Here is a real image from a plotting of the animals. For example, here we have 4 aquarium as a control. We see that the exploration is more general in 4 aquariums when compared, for example, to this, to 10 milligrams per liter, where you can see that fish stay more time at the bottom of the tank. This data represent a realistic anxiety parameter. Well, we see that antibiotics cause anxiety-like behavior in zebrafish, right? And we decided to test Clonazepam, that is a benzodiazepine, have no effects on anxiety, on another parameters, just in anxiety. And we used this to see if the Clonazepam was effective to revert the anxiety caused by oxy, 10 milligrams per liter. So, in locomotor activity, we didn't observe any alteration, neither in distance or freezing and erratic movements. However, as we can see here, the animals spent more time in the top, the tank, compared with just animal exposed to oxy. In this parameter, time spent in the top, the Clonazepam reverted the effects of anxiety. However, entries in the top and the latency to first in the top weren't reverted by Clonazepam. Okay. We had anxiety, and we need try to another type of experience to see another parameters of anxiety. With this, we also tested the social interaction. Social interaction is a common test that use just one fish per time and divide for a virtual line the center of this aquarium, and you analyze the latency to stimulus zone. This is the stimulus zone, time spent in stimulus zone, and stimulus zone frequency. 3 parameters to see the interaction of the fish with a shoal. We know that zebrafish remain in shoal with a group of fish and prefer this. So we can see here that just in 20 milligrams per liter, the latency to enter the stimulus zone was reduced when compared to control. However, we can observe that time spent in stimulus zone was higher at 10 milligrams per liter, and stimulus zone frequency, that's the crossing to frequency of the shoal, was reduced when compared to control. Both behaviors indicated that was occurring a state of anxiety in zebrafish. Well, again, we had anxiety. We tried to test social interaction just in 10 milligrams per liter of oxy, but we included again Clonazepam to try revert these anxiety effects in social interaction. As you can see here, time spent in stimulus zone when we apply the Clonazepam reduced in relation just to oxy, and this indicates that again Clonazepam was effective in treat the effects caused by the antibiotic. But in another graphics, we can see this reversion caused by clonazepam? Well, we had an anxiety effect caused by the antibiotic exposure, né? Oxytetracycline, and we decided to analyze if this behavior was not a confusion with another type of behavior, like fair state of depression, that's mean altered cortisol. For this, we analyzed the whole body cortisol. That's a point to analyze if fish have anxiety and if fish have a state of fear or depression. Here we can see that the fish reduced the cortisol levels during 96-hour exposure to oxy. This may indicate that have anxiety effects. Why? Because if it was, for example, a fear or another condition such as depression, the cortisol levels tendency to stay upper than control. And again, in this part, we just used 10 milligrams per liter of the oxy and analyzed that if clonazepam was able to revert this parameter, but we can't see difference from clonazepam plus oxy versus oxy. So, three behaviors show you anxiety effects, and when we compare it with behavior similar in another condition such fear and depression, were totally different, indicating that had anxiety effects in zebrafish. Perfect. The question is, how would oxy causes anxiety-like behavior in zebrafish? If you imagine that's how antibiotics is able to cause anxiety in animals. We may imagine that would be direct in the brain. I think not, because oxy can't cross in the blood-brain barrier to act direct in the brain. Studies have demonstrated this. For another hand, you can see that serotonin levels reduction may regulate neurotransmitters. Is indicative that oxy causes a dysbiosis, and the reduction levels of serotonin causes an anxiety state in zebrafish. This is direct in the microbiome alteration. Easily, oxy kill a type specific of bacteria in the gut, and this causes a block in the gut-brain axis. This is an effect of oxy, and studies had been demonstrated that at 100 milligrams per liter of oxy in zebrafish during 5 days exposure was able to kill a specific type of bacteria on gut and reduce the levels of serotonin. This is a possible explanation where antibiotic may cause effects of anxiety in zebrafish. As a study limitation, we need to analyze if 10 milligrams per liter is able to reduce the serotonin levels and the effect in another type of molecules that may regulate the neurotransmitters and cause a state of anxiety in zebrafish. Thank you, everyone.
Thank you, Darlan. So while waiting for some question in the chat, sorry, I was mute. So while waiting for some question in the chat, thank you for your talk. I have just one or two questions myself. I was actually wondering if there is any paper showing how much clonazepam could affect the brain in zebrafish, because obviously you present it as a kind of treatment for like against the anxiety that is triggered by sorry, I already forget the name, the oxycycline. Thank you. Don't you think that maybe it's kind of balance the effect on anxiety, but could trigger any bad over effect on zebrafish brain?
I agree with your question. I think that's if the exposure to clonazepam was more than 10 minutes, maybe your idea is correct. But just 10 minutes is not enough to cause alteration on the brain, I think, because I had a reference with not effects in the brain and not behavior alteration in this concentration during 10 minutes exposure of clonazepam, right? But if the exposure was prolonged, maybe causes effects in the brain, I think.
Okay, thank you. So we have Abby George, who is first saying great talk, and asking, do you know why doses higher than 10 milligram per liter of oxytetracycline did not affect the latency to the top of the fishes in the first experiments?
Sorry, can you repeat the question?
Yeah, of course. So the question is, do you know why doses higher than 10 milligram per liter of oxytetracycline did not affect the latency to the top of the fishes in the first experiments?
No, not. I don't know exactly this, but I think that's when we compare the less concentration with the high, I think that's is not enough to cause difference in latency on the top.
Okay, thank you. So we have Said now, who is also saying great talk, awesome results. He is wondering if you measured the duration of time zebrafish spent at the bottom layer of the tank, if any.
Sorry, can you repeat?
Did you measure the duration of time zebrafish spent at the bottom layer of the tank?
No, I have no answer for this question.
So you did not measure this. And he's also asking why you did not use that. I mean, yeah, you did not measure it, so that's why you did not use it. But like, do you have any justification why you did not use this measurement of the time spent at the bottom of the tank?
No.
Okay.
I have not.
So we have Nureddin Kaikai. I hope that I say correctly your name. That's a great talk, and was asking, do you have an explanation to why lower dose has a high effect compared to the high dose? Yeah, it's coming. I think it's coming a bit with the other question of AB before.
I think that's because, for example, we have a specific type of bacteria in microbiome. Low doses have no effects enough to kill all types, than 100, for example. This may explain the state of anxiety in more expressive in 10 than in 100.
Okay, thank you. And so, like, we have time for one more question. Like, I was wondering, like, what is the main goal of your project in the end? Are you trying to find a solution for fish, or do you want to kind of make a parallel with human at some point? What is the goal of the project?
My first goal for the project is that antibiotics are spread in all water around the world, right? If the antibiotics is inside of water, we are constantly exposed to antibiotics. And if you consider a translational study, zebrafish serve as a model to give us information regarding the effects of anxiety in antibiotic. I think that's is to first prevent the other to don't give us some toxic effects point to causes anxiety in humans, for example. The first, I think.
So like your main
And
goal is more human related, but not that. Yeah, okay, is more human related. Okay. Okay, thank you, Darlan. So like we are done with this second session.